Example on complex number. If Z satisfies the condition mod Z minus 1 is equal to mod Z plus 1, then show that the identity represent imaginary axis. That is real part of Z is 0. In other words, real part of Z is 0. That is identity represent imaginary axis. So squaring both sides. No need of this figure. Directly write squaring both sides. This is given. And what do I have to show? We have to show real part of Z is 0. That is this identity represent imaginary axis. So squaring both sides, what we have? Mod Z square. What is mod Z square? Is Z into Z bar. We know that mod Z square is what? Z into Z bar. Here is right. The mod Z square is Z into Z bar. Right here reason that mod Z square is right here reason mod Z square is Z into Z bar. So mod Z minus 1 square is Z minus 1 into Z minus 1 bar. Similarly, here is mod Z plus 1 brackets square is what? Z plus 1 into Z plus 1 bar. So right here is as mod Z square is Z into Z bar. And then Z1 minus Z2 bar is Z1 bar minus Z2 bar. That is Z minus 1 bar is what? Z bar minus 1 bar. And 1 bar is itself. If the number is a real number, then its conjugate is itself. Its bar is itself. If Z is x plus iy, then what is Z bar? X minus iy. But if the Z is number x, then what is its Z bar? Is itself x. That is, if the imaginary part, that is the number, is real number, then its conjugate is itself. So 1 bar is 1. Actually, Z minus 1 bar is what? Z bar minus 1 bar. But 1 bar is itself 1. Similarly here, Z bar plus 1 bar is 1. And then multiplication of these two brackets, Z into Z bar, Z into minus 1 is minus Z, Z minus 1 into Z bar is minus Z, and minus 1 multiplication plus 1. Similarly, multiplication of these two brackets, we have these 4 terms. And then Z into Z bar and this Z into Z bar get cancelled, plus 1 and plus 1 get cancelled. And what we have? And shift this minus Z to right side, shift this minus Z bar to right side. So what we have? 2Z plus 2Z bar is equal to 0. Change the sides. So take 2 common. So what we have? Z plus Z bar is 0. And shift these 2 to right side. So Z plus Z bar is 0. And Z plus Z bar is 2 times real part of Z. We know the note that Z plus Z bar is 2 times real part of Z. So where is the definition of modulus? After the definition of modulus, this is the definition of modulus argument and the definition of modulus. This is the definition of modulus. And what is Z plus Z bar? This is the Z plus Z bar is 2 times real part of Z. Z plus Z bar is 2 times real part of Z. So what is Z? Z is x plus yi. Then Z bar is x minus iy. Conjugate. Where is the note? Conjugate. Definition of conjugate of, this is the definition of complex conjugate. Z is x plus yi. Then Z bar is x minus yi. And what is Z plus Z bar is 2 times real part of Z. Because Z plus Z bar is 2x. 2x means 2 times real part of Z. So Z plus Z bar is 2 times real part of x. Z, not x. So here is the example that this is the example. Z plus Z bar is 2 times real part of Z. Because Z is x plus yi, then Z bar is x minus yi. And x plus y and x minus y is 2x. 2x means what? 2x means real, 2 times real part of Z. X means real part of Z. And then shift to, then we have real part of Z is 0. That is this identity, this given identity represent imaginary axis. Next example, for any two complex number Z1 and Z2, show that this mod Z1 plus Z2 square plus mod Z1 minus Z2 square is 2 times in bracket mod Z1 square plus mod Z2 square. And it's called law of parallelogram. It's also called law of parallelogram. So simplify this mod Z1 plus Z2 square. It is Z1 plus Z2. This is by using this identity that mod Z square is Z into Z bar. So Z1 plus Z2 into Z1 plus Z2 bar. and then separate the bar because Z1 plus Z2 bar is Z1 bar plus Z2 bar. Then multiplication of these two bracket is these four terms, Z1 into Z1 bar, Z1 into Z2, Z2 into Z1 bar, and Z2 into Z2 bar. This is suppose equation number 1. And then consider this mod Z1 minus Z2 square is again by using this rule, Z1 into Z2 into Z1 into Z2 this bar, and then Z1 bar minus Z2 bar next step, and then multiplication is this is suppose second, this is suppose second, Z1 into Z1 bar, Z1 into minus Z1 into Z2 bar, minus Z2 into Z1 bar, and minus minus plus Z1 into Z2 bar, and then adding equation number 1 and 2. So what do we have? Addition of this plus this is equal to, observe this, Z1 into Z2 bar and this minus Z1 into Z2 bar 0, and this Z2 into Z1 bar and this minus Z2 into Z1 bar becomes 0. So this Z1 into Z1 bar and this Z1 into Z1 bar is 2 times Z1 into Z1 bar, okay, and this is 2 times Z2 into Z2 bar, this plus this, okay. So write first that, and then Z1 into Z1 bar is mod Z1 square. So we have 2 times mod Z1 square, write that one more step, and this is Z1 into Z2 bar is what? Is mod, is 2 times, this addition is 2 times mod Z2 square. Take that 2 common, we have this 2 times mod Z1 square plus Z2 square. So write one more step here, that write Z1 into Z2 bar is what? Mod Z1 square. Right here that step. Then next example, prove that if mod A minus B divided by 1 minus A B bar is equal to 1, if and only mod A bar is 1 or mod B bar is 1. So this is if and only type. So the proof is in the 2 parts. So assume this, assume what? This mod is equal to 1 mod A minus B divided by 1 minus A into B bar is 1, and prove that either mod A bar is 1 or mod B bar is 1. So assume this in first part, this assume, and then what we have, separate the mod Z1 by Z2 is mod Z1 divided by mod Z2, and then shift this mod 1 minus AB bar to RHS, and then squaring both sides, and then use mod Z square is Z into Z bar. So this is A minus B into A minus B bar, and then similarly here the rule 1 minus AB bar is 1 minus its bar, total bar, okay. And what is the bar of 1 minus AB bar? Is 1 bar is 1 minus AB bar is what? A bar, B bar is B. So this is the way we have this, okay. 1 bar is 1 and A B bar is what? A bar, B bar is B, and then multiplication of these two bracket, we have these 4 terms. Multiplication of these 2 bracket, we have these 4 terms, and A into A bar is mod A square, and this minus AB bar and minus AB bar 0, minus BA bar and minus BA bar becomes 0, and this is mod B square 1 plus AB bar. This is A into A bar is mod A square, B into B bar is mod B square, okay, by using this rule. And then shift these terms to LHS. We have this mod this term, that is this LHS term to RHS, and change the sides. So minus A bar and minus B bar here terms, and then take mod A bars, mod A square as common factor. Then we have mod B square minus 1, and take plus sign common. We have 1 minus mod B square. That is actually take minus sign here common. Then we have mod B square minus 1, right here minus, and write in bracket mod B square minus 1, and then take mod B square minus 1 as common. Mod A square minus 1 is equal to 0. That is mod B square is, this is equal to 0 or this is equal to 0, and mod B square minus 1 is 0 means mod B square is 1 means mod B is 1, and mod A square minus 1 means mod A square is 1, that is mod A is 1. That is we have this either mod A square, mod A is 1 or mod B is 1. We have this, okay. Conversely, assume that mod one of them, this is true, either mod A is 1 or mod B is 1, and then prove this. So consider that mod A is 1. Assume that mod A is 1. This is the second part. And what do I have to show? Mod A minus B divided by 1 minus AB bar is equal to 1. So use A as a cos theta plus I sin theta, because its modulus is 1. So this is the polar form. Actually, what is the polar form of n in a complex number? Here a and b are complex numbers. So what is the polar form? That r in bracket cos theta plus I sin theta. What is r? R is modulus, but modulus of a is 1, therefore we have cos theta plus I sin theta. And similarly, we assume the b in a polar form as r in bracket cos phi plus I sin phi, or if we multiply by r, then we have r cos phi plus I sin r sin phi. So here is the theta notation, so use here phi notation, or either here use theta 1 and here theta 2 theta 2. Okay, so these a and b are two different complex numbers, and therefore their modulus and arguments are different. So here is this is the polar form of a and b, and then consider this. Separate the modulus of numerator and denominator, substitute the value of a and b. We have this, and then collect the real part, that is cos theta minus r cos phi is real part, and the coefficient of I is what? Take I as common, sin phi, theta minus r sin phi. Similarly, here multiplication of these two brackets, we have these four terms, and then collect the real part and imaginary part. This is the real part, and this is the imaginary part, that is the coefficient of I. Okay, and then what is the modulus of this number? This is the number in the form x plus iy, and so modulus of any number x plus iy is what? Root a square plus root x square plus y square. What is the modulus of x plus yi? Is x square plus y square, root x square plus y square, root square of this plus square of this number, coefficient of I, imaginary part square. Similarly, here the modulus of this number is what? Square of real part, x square, plus coefficient of I is minus r, but this square is plus r square, and square of this bracket, square of this bracket. Okay, so write that first, square of this bracket. Actually, this is what? This is sin theta cos phi minus cos theta sin phi is sin theta minus phi. This is the value of sin theta minus phi. And this is, if you take r as common factor, write one more step, take r as minus r as common factor, then we have sin theta sin phi cos phi is cos theta minus phi, cos theta minus phi. Write the value, and the value of this is what? Sin theta minus phi. And then its square is what? 1 minus r, this r, value of this remaining quantity is what? Cos theta minus phi bracket square, and the value of this bracket is what? Sin theta minus phi, and its square is what? R square. Its square of r is what? Negative r square is r square, and this, the value of this is sin theta minus phi, its square is sin square theta minus phi. And then square of this quantity, we have this square, and that is 2 times minus 2 times cos theta cos phi minus 2 times r cos theta cos phi, and this is minus 2 times r sin theta sin phi. Its square is sin square theta, this is r sin square phi, and that is equal to 1. Cos square theta plus sin square theta is 1, and minus then r square cos square phi plus r square sin square phi is what? Is r square, because sin square phi plus cos square phi is 1, minus 2r, take the 2r minus 2r as common, then we have what? Cos theta cos phi minus sin theta sin phi. That is, first write the square of this bracket, write the square of this bracket, and then we have this step. Similarly, square of this bracket, right? Square of this bracket, square of actually, and so what is the square of this? 1 square is 1, and minus 2 times r cos theta minus phi, this is the term minus 2r cos theta minus phi, and then r square cos square theta minus phi, r square sin square theta minus phi becomes r square. This is the term, and then we have the value of this bracket is what? Cos theta cos phi plus sin theta sin phi is cos theta minus phi. So we have the similar terms in the numerator and denominator, and therefore their multiplication division is 1. So this is the second part of the example. So in the first part, assume this and prove mod A is 1 or mod B is 1, and in the second part, assume mod A is 1, and then we have this, that is this value of this quantity is 1. Next example, z0 is x0 plus iy0, and a is greater than 0, be any real number. Then show that this equation mod z minus z0 is equal to a, represent the circle with center z0 and radius a. So suppose z as x plus yi as a complex number, and z0 is given x0 plus iy0. Substitute z as z0, and then take the real part in one bracket and imaginary part, that is the coefficient of I, and then its modulus is what? It's square of real part x square plus y square, square of this is equal to a square. Then taking square of both sides, we have x minus x naught square plus y minus y naught square is equal to a square. And this is the equation of circle with center x naught y naught and radius e. That is this identity, this equation represents circle with center z naught. Center z naught means what? X naught y naught in order pair form, x naught comma y naught. So and the radius is a. So the next example is suppose Z, A is this complex number, B is this complex number, and lambda is the angle between them. Okay, and then what is the argument of Z minus A divided by Z minus B is the angle between them, lambda. So what is the angle lambda? Is Z minus A. Argument of Z minus A by Z minus B is the angle between these two vectors, two complex number A and B. Okay. So this is the example. Z1 and Z2, Z3 represent three vertices of equilateral triangle, and then prove that this. Okay. So these Z1, Z2 are the vertices of equilateral triangle, means mod Z1 minus Z2. What is the mod Z1 minus Z2 meaning? The distance between Z1 and Z2. The distance between Z2 and Z3, and the distance between Z3 and Z1, and these three are same because these are the vertices of equilateral triangle. Equilateral triangle means what? The all sides are same. So this is mod Z1 minus Z2 is what? Actually it is the distance between Z1 and Z2, because if you write Z1, if you take Z1 as x1 plus iy1, Z2 as x2 plus iy2, then what is Z1 minus Z2 is this. If we observe here, suppose if I take Z as x plus yi and Z naught is x naught minus y naught, then this is the simplification, a real part and imaginary part. And what is its root x minus x naught square plus y minus 1? What is this? This is the distance formula, distance between Z and Z naught, this distance between this and this. Okay, root, because we know the distance formula. If the coordinates of the points are x1, y1 and x2, y2, then what is the distance? Root x1 minus x2 square plus y1 minus y2 square. So that is mod Z minus Z naught means the distance between Z and Z naught. Like that, the mod Z1 minus Z2 means what? Distance between Z1 and Z2. So all these three sides of equilateral triangle are same. Therefore, we have this, and the angle are also same. All the three angles. That is argument. Argument Z1 minus Z2 divided by Z1 minus Z3 is what? Is the angle between Z2 and Z3. Okay, like that, because of this note. What is argument of Z minus A by Z minus B is lambda, angle between them. That is this is ZA, this is ZB, then mod Z minus, argument of Z minus A by Z minus B is angle between them. So argument of Z1 minus Z2 divided by Z1 minus Z3 is pi by 3, because this Z1, Z2, Z3 are the vertices of equilateral triangle, means all the three angles are 60. Okay, so this is the angle between Z2 and Z3. This is the angle between Z3 and Z1. Okay, so all these angles are same. So we have this. Then we have from this that mod Z1 minus Z2 divided by mod Z1 minus Z3 is 1, and mod Z2 minus Z3 divided by mod Z2 minus Z1 is 1. Okay, because all these three are equal. Okay, and the modulus of these two numbers, that is Z1 minus Z2 divided by Z1 minus Z3, Z2 minus Z3 divided by Z2 minus Z1, modulus are same. Their modulus are same, arguments are same, and therefore these two numbers are same. When two numbers are equal, if their real part and imaginary parts are same, or when the two complex numbers are equal, if their arguments are same and modulus are same. So argument and modulus of these two numbers, this number and this number are same, and therefore these two numbers are same. Then simplify this, that is shift this Z2 minus Z1 to LHS, we have this side, and then Z1 minus Z3 to RHS, we have this side. And if we multiply these two brackets, then we have this, and that is we have to show. Next is mod Z1, mod Z2, and mod Z3, all are 5, and Z1 plus Z2 plus Z3 is 0. Then prove that this. So consider LHS of this. 1 by Z1 plus 1 by Z2 plus 1 by Z3. Then multiply and divide by Z1 bar, because we had to find the division. 1 by Z1, Z1. Multiply or rationalize the denominator. Multiply by Z1 its complex and divide by its complex. Similarly here, multiply by Z2 and divide by Z2 bar, multiply by Z2 bar. And here is also multiply and divide by Z3 bar. And then Z1 into Z1 bar is mod Z1 square. This is mod Z2 square, mod Z3 square. And Z1, mod Z1, mod Z2, mod Z3 are 5, its square are 25. And then take as 1 by 25 as common. 1 Z1 plus Z2 plus Z3, it's separate bar, then aggregate bar. Because we know that Z1 plus Z2 bar is what? Z1 bar plus Z2 bar by using definition of conjugate. And then we have this. And Z1 plus Z2 plus Z3 is what? 0. And 0 bar is itself 0. So 0 into 1 by 25 is 0. So we have 0 answer. So if mod Z1 minus Z2 is equal to mod Z1 plus Z2, then show that argument of Z1 and argument of Z2 differ by. That differ by means their difference. Difference between this argument of Z1 minus argument of Z2 is either pi by 2 or minus pi by 2. So this is the given. So consider that inequality, equality, not inequality. And squaring both sides of this side. Then apply the rule Z into Z bar is Z into Z bar, Z into Z bar. And then separate bar. And then their multiplication, we have this, and the similar factor get cancelled. Then Z1 into Z1 bar plus this Z1 into Z1 bar get cancelled, and then Z1, this minus Z1 Z2 shift to LHS RHS, we have plus Z1 into Z2 bar is 2 times, then this is 2 times, and then take 2 as common, and then shift to then Z1 plus Z2 bar, and write the Z2 into Z1 bar as this Z1 into Z2 bar. If we simplify, then what we have? Z1 bar into Z1 bar, this term, and then Z2 bar is Z2. We have this. And Z plus Z bar is 2 times real part of Z. So this is the number Z1 into Z2 bar, and its modulus is its conjugate becomes 2 times real part of Z1 into Z2 bar by using this property. And then shift the 2 times real part of Z1 into Z2 bar is 0, and Z1 into Z2 bar is purely imaginary number, and therefore its argument is what? Argument is pi by 2 or minus pi by 2. Why is imaginary number? Z1 into Z2 bar is purely imaginary number because real part is 0. Its real part is 0. Real part of Z1 into Z2 bar is 0, means it is a purely real, imaginary number. That is, it lies on the y-axis. And if the number lies on the y-axis, then its argument, that is axis y, makes an angle pi, positive y-axis makes an angle pi with positive x-axis, and negative y-axis makes minus pi by 2 angle with positive x-axis. And therefore this number, real part of this number is 0, means this number is purely imaginary. And if the number is purely imaginary, then its modulus, its argument is pi by 2 or minus pi by 2. And argument of Z into Z1 into Z2 bar is what? Argument of Z1 plus argument of Z2 bar. Because we know the theorem that argument of Z1 into Z2 is what? Argument of Z1 plus argument of Z2. The conversion of multiplication to addition. And argument of Z2 bar and argument of Z bar. What is argument of Z bar? Is minus argument of Z. So argument of Z2 bar is what? Minus argument of Z2, and that is the difference between these two is either pi by 2 or minus pi by 2. So these are some problems for homework, for assignment. So solve these all exercise problems. So verify the property of theorem 3. This is the theorem 3. We have to verify these properties for these numbers. So these are the examples on this topic. Their answers are also given. So solve all these exercise number 6.2, exercise number 6.3, their answers are given. So solve all these problems and share me through WhatsApp group. Their answers share me through WhatsApp group.